Hello students, welcome to my video lecture. First Brahmanath. Om Shanti Shanti Shanti. Last class we discussed permutation. Simply definition of permutations and notation. Okay, so out of n different things taken r at a time, when one is less than is equal to r, less than is equal to n, then total number of permutations is equal to npr is equal to n into n minus 1 into n minus 2 dot 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 n minus r plus 1 also is equal to n factorial divided by n minus r factorial. Okay, means out of n different things taken r at a time, total number of permutation is equal to what? npr. So is equal to factorial n divided by factorial n minus r, condition 1 less than is equal to r, less than is equal to n, also is equal to n into n minus 1 into n minus 2 dot 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 n minus r plus 1 ila npr. If in this case repetition is not allowed, if the repetition is allowed, then total number of permutation of n different things taken r at time, and each thing is repeated r times, then total number of ways is equal to n into n into n up to r times is equal to n to power r. Here repetition allowed, in this case repetition allowed, in this case repetition not allowed. Okay, today we are going to discuss some problems of npr, okay, and restricted permutation also. Prove that npr is equal to n minus 1 pr plus r into n minus 1 pr minus 1. Okay, the proof RHS part, RHS n minus 1 pr plus r into n minus 1 pr minus 1. To expand n minus 1 pr, to use npr formula, this is n minus 1 factorial divided by n minus 1 minus r factorial plus r into this also n minus 1 factorial divided by n minus 1 minus of r minus 1. It becomes r plus 1 factorial. Okay, 1 cancel. So is equal to n minus 1 factorial divided by n minus r minus 1 factorial plus r into n minus 1 factorial divided by this is n minus r factorial. Okay, so here n minus 1 factorial is common. Okay, so this is 1 by n minus r minus 1 factorial plus r divided by n minus r factorial. Okay, so here n minus r minus 1 factorial and n minus r factorial. So LCM of these two is equal to n minus r factorial. So LCM always taking greater 1. So this is greater than n minus r minus 1 is less than n minus 1. So LCM is n minus r factorial. So is equal to n minus 1 factorial into LCM is n minus r factorial. So n minus r factorial divided by n minus r minus 1 factorial is equal to n minus r. So put here n minus r plus n minus r factorial divided by n minus r factorial is 1 into r is r. So r cancel. Okay, so is equal to n minus 1 factorial into n divided by n minus r factorial is equal to n into n minus 1 factorial. N minus 1 factorial means 1 into 2 into 3 up to n minus 1 into n is equal to factorial n divided by n minus r factorial is equal to npr is equal to what? npr is equal to LHS. Okay, तो therefore NPR is equal to n minus 1 PR plus R into n minus 1 PR minus 1. Okay. Next question, find n if 2n minus 1 Pn is to 2n plus 1 Pn minus 1 is equal to 22 is to 7. Okay. The solution given 2n minus 1 Pn is to 2n plus 1 Pn minus 1 is equal to 22 is to 7. So use the formula NPR. So it becomes 2n minus 1 factorial divided by 2n minus 1 minus n factorial. Okay. Whole divided by, this is 2n plus 1 factorial divided by 2n plus 1 minus n plus 1 factorial is equal to 22 by 7. Okay. So implies this is 2n minus 1 factorial divided by 2n minus n, so it is n minus 1 factorial. Okay. Into this is कौन हम ये चली जो ऊपर को, तो 2n minus n is n, तो n 1 plus 1 2, तो n plus 2 factorial divided by it is 2n plus 1 factorial. Okay, is equal to 22 divided by 7. Okay, so here 2n minus 1 is less than 2n plus 1 and 2n minus 1 is nearer to 2n plus 1, so 2n plus 1 break the 2n plus 1. Similarly, n minus 1 is less than n plus 2 and n minus 1 is nearer to n plus 2, so break n plus 2. Okay, so this implies the 2n minus 1 factorial divided, okay, 2n minus 1 factorial divided by n minus 1 factorial into, so n plus 2 factorial means n plus 2 into n plus 1 into n minus 1 factorial means n minus 1 factorial आसला पर्यंत आपको कौन करिवो रेड्यूस करके जाउथु n plus 2 then n plus 2 minus 1 then n plus 2 minus 2 then n plus 2 minus 3, that is n minus 1 factorial. Hela similarly 2n plus 1 factorial means 2n plus 1 first asla 2n plus 1 then 1 minus कर दलो 2n again 1 minus करले 2n minus 1 factorial means ए ऊपर आसला पर्यंत हम कंटिन्यू करथिबा is equal to 22 divided by 7, 22 divided by 7. Okay. तो n minus 1 factorial cancel, 2n minus 1 factorial को 2n minus 1 factorial cancel. तो रला कौन देखा इधे बे, this is n plus 2 into n plus 1 into n divided by 2n plus 1 into 2n is equal to 22 divided by 7. तो n को n cancel. Okay. Okay, so implies multiply this is n square plus 3n plus 2 divided by 4n plus 2 is equal to 22 by 7. Cross multiplication करो, 7n square plus 21n plus 14 is equal to 88n plus 44. 88n plus 44. Taking one side, so 7n square minus 88n minus 20, 68, so minus 67n. This is minus 30 is equal to 0. Minus 30 is equal to 0. And simplifying, we get the value of n. And simplifying, we get the value of n. Okay. So is equal implies 7n square minus 17n plus 3n minus 30 is equal to 0. So implies 7n, so n minus 10 plus 3 taking 3 is common, n minus 10 is equal to 0. So implies n minus 10 into 7n plus 3 is equal to 0. So implies n is equal to 10 out n is equal to minus 3 by 7 does not belongs to natural number. Therefore, n is equal to 10. This is the answer. Find the value of n. So n is equal to 10. Okay. Next question. Find m and n if p m plus n comma 2 is equal to 90 and p m minus n comma 2 is equal to 30. So, solution given p m plus n comma 2 is equal to 90. That means this is m plus n p2 is equal to 90. So this is m plus n factorial divided by m plus n minus 2 factorial is equal to 90. Okay. Okay. m plus n factorial divided by m plus n minus 2 factorial is equal to 90. So here m plus n is greater than m plus n minus 2. So expand m plus n. So this is m plus n into m plus n minus 1 into m plus n minus 2 factorial divided by m plus n minus 2 factorial is equal to 90. So cancel this. This is m plus n into m plus n minus 1 is equal to 90. So m plus n and m plus n minus 1 is the product of two consecutive number. These are the product of two consecutive number. So express 90 as the product of two consecutive number. So first one is greater than second one because m plus n is greater than m plus n minus 1. So 90 means 10 into 9. So this is equal to 10 into 9. So equating both sides, we get m plus n is equal to 10. This is equation 1. m plus n is equal to 10. Again p m minus n comma 2 is equal to 30. This is m minus n factorial divided by m minus n minus 2 factorial is equal to 30. So implies m minus n is greater than m minus n minus 2. So expand m minus n factorial. So this is m minus n into m minus n minus 1 into m minus n minus 2 factorial divided by m minus n minus 2 factorial is equal to 30. Cancel this. So m minus n into m minus n minus 1 is the product of two conjugate number. So express 30 is the product of two conjugate number. So first one is greater than the second one. So express 30 means 6 into 5. 6 into 5, that means 6 and 5 are two conjugate number. So equating both sides, we get m minus n is equal to 6. Equation 2, m minus n is equal to 6. So solving 1 and 2. So 1 plus 2 is equal to what? 2m. 2m is equal to 16. So m is equal to 8. Therefore n is equal to 4 because n is equal to 2 because m is 8. So 8 plus n is equal to 10. So n is equal to 2. Hence m is equal to 8, n is equal to 2. Okay. Next question. In how many ways the letter of the following words can be arranged? Okay, the letters of the following words can be arranged. Question number 1, God. Next 2, tower. 3, combine. 4, fraction. Okay, so solution 1. The word God contains 3 letters. The word God contains 3 distinct letters. Then total number of permutation, then the total number of arrangement, then the total number of arrangement taking 3 letters out of 3 letters at a time. Taking all letters at a time is equal to 3p3. that is equal to 3 factorial is equal to 6. Means 6 ways we can arrange the letter of the word God. Okay, and they are, and the arrangements are God, GDO means OD interchange. So first letter is G in first and second case. In the second letter O, D, G, then O fix, DG interchange, GD. Next first letter is suppose D, DOG, then D fix, OG interchange, DGO. So 1, 2, 3, 4, 5, 6. So these are the 6 arrangements. Okay. Similarly, question number 2. Question number 2, the word tower. The word tower contains 5 letters. Contains 5 distinct letters. Therefore, the total number of permutation, the total number of arrangements taking all the letters at a time, taking all the letters of the word, taking all the letters of the word at a time is equal to 5p5 is equal to 5 factorial. That means 120. So 120 the word formation kariba using the letters of the word tower. Okay. Similarly, we can do question number 3 and 4. Okay. This is a very interesting questions. Find the number of permutations that can be formed from the letters of the word data. Question number 1, taking all the letters without any restriction. Taking all the letters, sabu letter nabo without any restriction. No restrictions are there. Okay. So question number 1. Solution. Total number of letters of the word daughter. Number of letters of the word daughter is equal to 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. D-A-U-G-H-T-E-R. Sorry, T-E-R. So 8. 8 all are distinct. Okay. So question number 1. Taking all the letters without any restriction means out of 8 letters taking all at a time. Okay, out of 8 letters taking all at a time. Okay, out of 8 letters taking all at a time. Total number of arrangements means 8p8 out of 8 letters means n is 8 taking all at a time means r also 8. So 8p8 is equal to 8 factorial 40320. So this is equal to 40320. Next question number 2. Okay. So question number 2 what? Beginning with D. So since there are 8 letters, since the word daughter contains 8 letters, so therefore 8 boxes means this is the 8 boxes. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. So 8 boxes are there. So beginning with D. So this is first box is, in first box we can write D, means first box we can write D, then other 7 boxes are there. This is fixed, D is fixed in first box. So other 7 boxes are there and also 7 letters are there. So 7 boxes can be filled in 7 ways. Okay. Since D lies on first box, second number, since D lies on first box, so first box can be filled in one way. So first box can be filled in one way, can be filled in one ways. Okay. Now there are 7 boxes, 7. Now there are remaining 7 boxes. Now there are remaining 7 boxes and remaining 7 letters. Remaining 7 boxes and remaining 7 letters. Taking 7 letters at a time, taking all the letters at a time. Okay. So remaining 7 places can be filled out by remaining 7 places can be filled by remaining 7 letters. Remaining 7 letters in 7p7, that is 7 factorial ways, is equal to 30. 7 factorial means 5040. 5040 ways. Okay. This is question number 2. Next, question number 3. Question number 3, beginning with D and ending with R. So first box and last box already filled in one ways. Beginning with D and ending with R. Therefore, first and last box can be filled in one ways. This is 1 2 3 4 5 6 7. 1 2 3 4 5 6 7 8. So beginning with D and ending with R. So first and last places can be filled in one ways. First and last places can be filled in one ways. The remaining 6 places can be filled, remaining 6 letters in 6p6 ways, that is 6 factorial ways. Okay, that is 720 ways. Okay. Now the second to 7th place, the remaining 6 places remaining. Now the remaining 6 places can be filled by remaining 6 letters. Remaining 6 letters, and this can be done in Now the remaining 6 places can be filled by remaining 6 letters. Okay, so number of ways is equal to 6p6, that is 6 factorial, 720 ways. Okay, so question number 3 is over. Question number 4, D and R occupying AND places. D and R occupying AND places. 1 2 3 4 5 6 1 2 3 4 5 6 7 8. So D and R occupying AND places means here suppose D lies in the 7th place, R lies in the 8th place, or R lies in the 7th place, D lies in 8th places. So last two places can be filled in 2 different ways. Okay, since given that D and R lies in AND places, so it can be done in 2 different ways. So it can be done in 2 different ways. Because if we write here dr or rd, so 2 different ways. Now remaining 1 2 3 4 5 6, now remaining 6 places. Now the remaining 6 places can be filled by, now remaining 6 places can be filled by remaining 6 letters, It can be done in 6p6, that is 6 factorial ways. Okay, therefore by fundamental principle of multiplication, counting the total number of possible ways, when D and R lies on D and R occupying AND places, is equal to 2 into 7 factorial. So is equal to 2 into 7 factorial means 6 factorial, not 7 factorial, 6 factorial. So 2 into 6 factorial means 720 is equal to 1440. Okay, 1440 ways. Last 2 places कौन है? Last even कौन है जी? D and R occupying AND places. Okay, sorry, D and R occupying AND places means this is D and R this way, or R out D this way, Okay, so this is answer is 2 into 720, either first and last, first ending or last, है नहीं, means first place and ending place. ठीक है. Question number 3 is what? Beginning with D and ending with R. This is fixed. First रे D रहिबो, ending रे R रहिबो. But here first रे D, ending रे R, or first रे R, ending रे D. So there are 2 cases. Okay. So 2 cases are there. So hence total number of ways equal to 2 into 720. Okay. Next question, vowels being always together means all vowels are always together means सब जगह vowels गोटे थारे ही रहिबो. Okay, तो in this case देखो question number 5, Daughter means A-U-E. There are three vowels. There are three vowels. There are three vowels. A-E-U. There are three vowels in the word daughter. In the word daughter. Okay. So all the three vowels come together. All the three vowels come together. The together word दिया है देखो. तो in this case three vowels take as one unit. Three vowels take as one unit. Okay. So there are out of 8 letters, means there are 8 letters. So total number of letters. Now the total number of, so one unit means three vowels take as one unit or one letter. Therefore the total number of letters is equal to number of letters is equal to 8 minus 3 plus 1 is equal to 6, because there are 8 letters in the word daughter. तो three vowels take as one letter. तीन जाक vowels को हम गोटे ही नेले, तो गोटे letter नेला, तो total number letter कितना है? 8 minus 3 plus 1, कहीं हम गोटे letter नहीं तक नहीं चाहिए, तो 6. तो 6 letter can be arranged in a row. 6 letters can be arranged in a row in 6 factorial ways. Now the three vowels arranged among themselves. Now the three vowels arranged among themselves. In 3 factorial ways, 3p3 ways. 3p3, that means 3 factorial ways. Hence by fundamental principle of counting, total number of such ways is equal to 6 factorial into 3 factorial. 6p6 means 6 factorial into 3 factorial, that is 720 into 6. 3 factorial means 6. Okay, 6 0 0, 6 2 12 2, 6 7 42, 1 43, 4320 ways. 4320 ways. Okay. Next question number 6. Not all vowels together. सब जगह vowels एकाठी रहे नहीं. Not all vowels together. Okay. So in this case, the number of words here, we take not all vowels together. Here we take not all vowels together. This is very simple. Question number 1 means 1, question number 1 minus question number 5. That means first taking all the vowels without any restriction. First taking number of words, taking all the letters of the word daughter without any restriction, minus all vowels always together. All vowels Okay, so question number 1 minus question number 5 we get question number 6. Okay, so here the required number of words is equal to the required number of words. The required number of words is equal to all the letters of the word, all the letters of the word daughter without any restriction. Okay, or total number of possible word, total number of possible word, total number of possible words using the letters of using the letters of the word daughter minus without any restriction, without any restriction, minus all the vowels, number of words with all vowels together, number of words with all vowels together, with all vowels together is equal to, this is 8p8 minus 7 factorial into 3 factorial, sorry 6 factorial into 3 factorial, this is 6 factorial into 3 factorial, that is 8 factorial minus 6 factorial into 3 factorial, so is equal to, this is 8 factorial means what? 8 factorial means 40320 minus 4320 is equal to 0 minus 0 0, 2 minus 2 0, 3 minus 3 0, so 0 minus 4 6, this is 3, 3 6 0 0, 3 6 0 0, this is the answer. This is the question number 6. Okay, next question number 7. Question number 7, no two vowels together, तार तो दुईटा vowels at a time आसिया को हबनी, दुईटा vowel मझरे किसी एक्स्ट्रा रहा पड़िबो. ओके, नले दुईटा एक्स्ट्रा लेटर मझरे गोटे vowel रहबे. ओके, no two vowels come together, no two vowels together. Okay, so here the word daughter contains 3 vowels. The word daughter one, two, three, 4, 5, 6, 7, 8. Daughter contains 3 vowels and 5 consonant. Okay, 5 consonant. Okay, so first 5 consonant can be arranged in a row. Now number of number of 5 consonants can be arranged in a row. First arrange the consonant. First arrange all the consonant in a row. And number of ways in first arrange all the consonants in a row in 5p5 ways is equal to 5 factorial, that is 120 ways. because no two vowels come together. तो vowels ऊपर आमर रेस्ट्रिक्शन आस तो vowels को फिक्स कर रखी छाड़ दियो. तो फर्स्ट कॉन्सोनेंट को आम कौन करिए अरेंज करिबा. तो 5 कॉन्सोनेंट्स आर देयर इन द वर्ड कंटेन्स डॉटर. ओके, तो फर्स्ट अरेंज 5 कॉन्सोनेंट इन ए रो इन 5 फैक्टोरियल वेज. अच्छा, तो दिस इज कॉन्सोनेंट सरी इधर है देखो 1 consonant, 2 consonant, 3 consonant, 4 consonant, 5 consonant. It is C, 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 C. C for consonant, V for vowels. C for consonants. V for vowels. So there are 1, 2, 3, 4, 5, 6 gaps. There are 6 gaps among 5 consonants. There are 6 gaps among 5 consonants, and that 6 gaps 1, 2, 3, 4, 5, 6. So that 6 gaps are occupied by 3 vowels. And this can be done in 6p3 ways. 6p3 ways. Hence total number of such arrangement. Total number of such arrangement is equal to what? 5 factorial into 6p3 by fundamental principle of counting. 5 factorial into 6p3. 5 factorial into 6p3. Okay? By fundamental principle of counting means number of words no 2 vowels come together is equal to 5 factorial into 6p3. 5 factorial into 6p3 is equal to 5 factorial means 120 into 6p3. 6 factorial by 3 factorial. So 6 into 5 into 4. 6 into 5. 30 into 4. 120. So 120 is equal to 14400. Okay. Next question. Vowels occupying even places. Vowels 8 number. Vowels occupying even places. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So this is 1, 2, 3, 4, 5, 6, 7, 8. So 2, 4, 6, 8. There are 4 even places. So it can have vowels. So how many even places? 4 even places, but 3 vowels. So there are 4 even places. There are 4 even places. So that place are occupied by that places are occupied by 3 vowels. This can be done in 4p3, that is 4 factorial ways. Okay, that is 24. Okay, এই তিনটি জায়গায় কি রহিব यही चार जगह भावेल रहिबे किंतु चारिटा जगह सिना चारिटा प्लेस किंतु तीनटा लेटर तो तीनटा लेटर फिलअप होला पर आउ पांचटा बॉक्स पांचटा प्लेस रहिबो हला नहीं गोटे इवन प्लेस आउ चारिटा ऑड प्लेस तो पांचटा प्लेस रे पांचटा कौन रहिबे आमर 5 प्लेस रे 5 कॉन्सोनेंट रहिबे नाउ remaining 5 places can be filled by now remaining 5 places can be filled by now remaining 5 places can be filled by remaining 5 letters. Remaining 5 letters. It can be done in 5p5 that is 5 factorial is equal to 120 ways. Hence by fundamental principle of counting total number of such ways is equal to 24 into 120. 2880 ways. 2880 ways. Okay. Next question. Find the number of ways in which 5 boys and 5 girls be seated in a row so that no restriction. एटा मो देख लिखियार नहीं खाली बुझी दो देख टिके हैला तो देयर आर 5 बॉयज एंड 5 गर्ल्स तो टोटल नंबर ऑफ पर्सन्स इज इक्वल टू 5 प्लस 5 दैट इज 10 तो 10 persons can be seated in a row in 10p10 ways तो 10 factorial ways तो क्वेश्चन नंबर 1 no restriction means without any restriction means total number of persons can be seated in a row in 10p10 ways that is 10 factorial ways तो क्वेश्चन नंबर 1 आंसर ऑफ क्वेश्चन नंबर 1 is 10 factorial ways okay next question number 2 no two girls may sit together means दुईटा girls पाखापाखि बसी पारे ना तो अर्थ दुईटा बॉयज बसी पारे में रेस्ट्रिक्शन ना तो फर्स्ट रेस्ट्रिक्शन इज कहाँ पे अच्छी गर्ल्स पे अच्छी तो फर्स्ट आम अरेंज द 5 बॉयज इन ए रो बिकज बॉय मान रेस्ट्रिक्शन ना तो फर्स्ट बॉयज को अरेंज कर दियो इन ए रो रे तो 5 बॉयज कैन बी अरेंज्ड इन ए रो इन 5 factorial ways तो 5 boys can be arranged in a row in 5 factorial ways okay so there are 6 gaps among the 5 boys 1 2 3 4 5 6 there are 6 gaps among the 5 boys so that 6 gaps are occupied by girls because no two girls sit together तो यही जो 6 गैप रे किए बसबे ना गर्ल्स बसबे केतरा गर्ल्स अच्छे 5टा गर्ल्स तो 5 गर्ल्स can be arranged in 6 gaps in 6p5 ways 5 girls can be arranged in 6 gaps these 6 gaps in 6p5 ways तो total number of arrangement by fundamental principle of counting 5 factorial into 6p5 5 factorial into 6p5 again question number 2 कौन करियो कहलो फर्स्ट 5 boys can be arranged in a row because boys मान तमर रेस्ट्रिक्शन ना फर्स्ट बॉयज को अरेंज कर दी इन रो रे तो केते बेरे 5 factorial 5p5 दैट इज 5 factorial नाउ देयर आर 6 गैप्स अमंग द 5 बॉयज 5 बॉय मझे 6टा गैप आसीबो दैट 6 गैप्स आर ऑक्युपाइड बाय 5 गर्ल्स and this can be done in 6p5 ways तो टोटल नंबर ऑफ सच अरेंजमेंट इज इक्वल टू 5 factorial into 6p5 तो क्वेश्चन नंबर 2 इज ओवर नेक्स्ट क्वेश्चन नंबर 3 all girls sit together means all girls treated as one person all girls treated as one person सब 5 जन गर्ल को आम गोटे पर्सन बोले ट्रीट करवा तो टोटल नंबर ऑफ पर्सन केते हेले 5 बॉयज 5 पर्सन 1 मीन्स 5 गर्ल्स इज 1 पर्सन तो टोटल नंबर ऑफ पर्सन इज इक्वल टू 6 5 boys 5 person and 5 girls can be taken as one person. So total number of person is equal to 6. So 6 person can be arranged in a row in 6 factorial ways. 6 person can be arranged in a row in 6 factorial ways. But now 5 girls arranged among themselves. 5टा गर्ल्स तांका भितर इंटरचेंज करेंगे इन केते 5 factorial ways. 5 girls arranged among themselves in 5 factorial ways. Therefore total number of such arrangement means all the girls sit together. Total number of such arrangement is equal to what? 6p5 into 5 factorial. 6p5 into 5 factorial. Again first हमें कौन कर ले? First से कौन कही? All the girls can be taken as one person. All girls can be taken as one person. 5 boys as 5 person. Total number of person is equal to 6. So 6 person can be arranged in a row in 6p6, that is 6 factorial ways. But 5 girls arranged among themselves in 5 factorial ways. So total number of such arrangement is equal to 6 factorial into 5 factorial. 6 factorial into 5 factorial. Next question number 4. Question number 4. All girls sit together, all boys sit together. सबुजा गर्ल्स मिसिक बसबे, सबुजा गर्ल्स बॉयज मिसिक बसबे. तो all girls can be taken as one person. All boys can also taken as one person. The total number of person is 2. The 2 person can be seated in a row in 2 factorial ways. 5 boys one side, 5 girls one side, then interchange. So 2 factorial ways. Now 5 boys are arranged among themselves in 5 factorial ways and 5 girls are arranged among themselves in 5 factorial ways. Hence by fundamental principle of counting, 2 factorial into 5 factorial into 5 factorial is the required answer. Okay, all girls taken as one unit, all boys taken as one unit. The total number of unit is equal to 2. 2 unit can be arranged in a row in 2 factorial ways. Now all girls can be arranged among themselves in 5 factorial ways. All girls can be arranged among themselves in 5 factorial ways. So total number of such arrangement is equal to 2 factorial into 5 factorial into 5 factorial. Okay. Next question number 5. All girls are never together. All girls are never together means first question number 1 minus question number 3. Question number 1 minus question number 3 means first without any restriction 10 person can be arranged in 10 factorial ways minus all girls को can be taken as 1 unit नंबर सबुजा girls गोटे थे बसे दबो तो कौन आसुटा 6p all girls can be taken as 1 unit तो 1 plus 5 6 factorial into 5 factorial. तो 10 factorial minus 6 factorial into 5 factorial कौन कर ले ना without any restriction minus all girls come together is equal to all girls are never come together. Next boys and girls sit alternately. The boys and girls sit alternately. एटा केतल पॉसिबल हबो जेतला number of boys is equal to number of girls or number of boys and number of girls with difference टा 1 थिबो हला difference टा either 0 or difference टा 1. अच्छा if the difference is 0 अच्छी ताले फर्स्ट कौन देखो एटी हम कौन करला boys boy यही गैप रे हमें काग सजे हमें गर्ल्स जो स्टार्टिंग करिवा बॉयज रे एंडिंग हबो गर्ल्स जो स्टार्टिंग करिवा गर्ल्स रे एंडिंग हबो बॉयज रे जी तो एटा केस 1 केस 2 जी बी ओके तो स्टार्टिंग करियो बॉयज रे एंडिंग हबो गर्ल्स स्टार्टिंग करियो गर्ल्स रे एंडिंग हबो बॉयज रे तो दुईटा केस आसीबो तो 2 into कौन करलो ना फर्स्ट बॉयज को सजे देलो 5 factorial ways तो नेक्स्ट देखो 5 boys तो 5 boys 1 2 3 4 5 तो 5 factorial ways. नेक्स्ट एटू स्टार्टिंग कर गर्ल्स 1 2 3 4 5 तो 5टा गैप अच्छी से 5टा गैप रे 5टा गर्ल्स बसी 5 factorial एपड़ स्टार्ट करि परियोनी कि स्टार्टिंग करती मु बॉयज रे एंडिंग करची गर्ल्स रे. ओके तो 5 factorial into again 5 factorial by फंडामेंटल प्रिंसिपल ऑफ मल्टीप्लिकेशन 2 into 5 factorial into 5 factorial कहीं दुईटा केस तो 2 फर्स्ट रे आरेंज कल बॉयज को ये गैप जार क्या अरेंज कल गर्ल्स को तो 5 फैक्टोरियल इंटू कौन 5 फैक्टोरियल ओके तो ये आम रिक्वायर्ड आंसर। नेक्स्ट वन रेस्ट्रिक्टेड परमुटेशन मीन्स परमुटेशन विथ रेस्ट्रिक्शन ओके अच्छा द नंबर ऑफ परमुटेशन ऑफ n different things taken are at a time when a particular thing is always included in each arrangement okay when a particular thing is always included in each arrangement okay one number of arrangements number of permutations of n different things taken are at a time when a particular thing is always included in each arrangement is equal to r into n minus 1 p r minus 1 r into n minus 1 p r minus 1 तो फास्ट देखो टोटल नंबर ऑफ थिंग्स n we can take r at a time तो पर्टिकुलर थिंग इज ऑलवेज इनक्लूडेड तो एवरी आरेंजमेंट रे गोटे पर्टिकुलर थिंग रहिबो तो आमे कौन कले ना ऊपर 1 माइनस कले तळु 1 माइनस कले कहीं ना सपोज देख दिस इज ए बॉक्स 1 2 3 4 5 तो देर आर ए बी सी डी ई देर आर 5 लेटर्स तो 5 लेटर टेकिंग 5 letters taking 3 at a time there are 5 letters taking 3 at a time condition is a is always included in each arrangement a रहिबो हैला नहीं प्रत्येक arrangement रे a रहिबो a is included in each arrangement okay then find the number of 3 lettered words using the letter of the word a b c d e ओके तो कौन हो देख जेहेतु एटा कौन हो आमर इच आरेंजमेंट रहा बाध्य तो ए को फिक्स करदेल तो ए को फिक्स कला कौन है एटा बर्तमान फिक्स है गोटे बॉक्स रे ए फिक्स हो गला तो आ केतुटा लेटर रहा आउ 4टा लेटर रहा केतुरा बॉक्स रहा 2टा बॉक्स रहा कहीं एटा बर्तमान फिक्स हो गला एटा गोटे बॉक्स रे फिक्स हो गला तो देयर आर 4 लेटर्स एंड 2 बॉक्सेस तो दिस कैन बी डन इन 4p2 ways दिस कैन बी डन इन 4p2 अर्थ 5 minus 1 p3 minus 1 दैट इज 4p2 ways ओके तो 4p2 ways आम अरेंजमेंट करि परिबा केमिति ना bc bd be cd ce de 1 2 3 4 5 6 तो 4p2 means 6 next a lies in either first place or second place or third place तो एटा जे कौन सी प्लेस रही पारिबो यदि ए जे फर्स्ट प्लेस रहिबो एला abc abd abe acd ace ad यदि ए जे सेकंड प्लेस रहिबो कौन हबो bac bad bae cad cae dae यदि a lies in third place it becomes bca bda bea cda cea dea तार अर्थ कौन हो 6 into 3 मीन्स 18 टाइम पाँच 3 मीन्स 3 ये 3टा बॉक्स अच्छी इंटू 3 तो ये आठ है 3 एंड है 5 r इज इक्वल टू 3 n इज इक्वल टू 5 तो जेहेतु 3टा बॉक्स अच्छी a लाइज इन एइदर फर्स्ट बॉक्स और सेकंड बॉक्स और थर्ड बॉक्स तो 3टा वे से रहीपर यहाँ तो इंटू कौन करा 3 तो इंटू 3 अर्थ इंटू r तो आंसर कौन है 3 इंटू 4p2 तो 3 कहले r इंटू 4 कहले 5 माइनस n माइनस 1 pr माइनस 1 तो r इज इक्वल टू 3 n मीन्स 4 n इज 5 माइनस 1 4 p 2 मीन्स 3 माइनस 1 मीन्स r माइनस 1 Okay, so when a particular thing is always included in each arrangement means कौन करिवो r into n minus 1 p r minus 1. Okay, second one, number of permutations of n different things taken r at a time when k particular things are always included in each arrangement is equal to n minus r p k minus r into r p k. n minus r p k minus r. Here देखो n minus 1 r is 1, तो n minus 1 p k minus 1 in this case into rp1. rp1 means r, np1 means n, rp1 means r. Okay, तो n minus r p k minus r into rpk. Okay, next 3, number of permutation of n different things taken r at a time when a particular thing never included in each arrangement is n minus 1 pr is equal to n minus 1 pr. देखो ना out of n different things taken r at a time, so total number of permutation means n pr. But here a particular thing is never included in each arrangement. गोटे बिल्कुल जेकोसी आरेंजमेंट से रोनी तार आम कौन करवा टोटल नंबर ऑफ थिंग गोटे को माइनस कर दियो जोटा रोनी, तो n minus 1 रो आर थिंग आम कौन करिया आम यूज करिया. एग्जांपल देखो, एग्जांपल n is equal to 5. Suppose A, B, C, D, E. There are 5 letters. R is equal to 3. Taking 3 at a time. Okay. तो एथरू कौन है 3 at time ना A, particular A always never included in each arrangement. एटा बिल्कुल रही कौ आरेंजमेंट भी ए रहा, तो एटा को काटिकी रेस्ट रू आम कौन करिया 3टा लेखा आम कौन करिया चूज करिया, मीन 3टा लेखा नहीं आम कौन करिया वर्ड फॉर्मेशन करिया. तो बी सी डी ई रु आम 3टा लेखा लेटर नहीं आम कौन करिया वर्ड फॉर्मेशन करिया. ओके, तो ए तार कौन टोटल थी 5टा लेटर आम एटा बिल्कुल निया होनी, तार कौन करिया 4टा लेटर रु आम 3टा लेखा लेटर नहीं वर्ड फॉर्मेशन करिया. दैट मीन्स 5 minus 1 pr. ओके, 3टा लेखे लेटर फॉर्मेशन करिवो जेमिति हेले, किंतु ए को छाड़ी बिकॉज ए इज नॉट यूज्ड इन ऑल द अरेंजमेंट, जेकोसी अरेंजमेंट रे ए रही, तो ए को छाड़ी रेस्ट आम कौन करिया है. नेक्स्ट आर जनरलाइजेशन फॉर्म अच्छी 4 नंबर ऑफ परमुटेशन of n different things taken r at a time when k particular thing never included in each arrangement is equal to n minus r p n minus k pr n minus k pr. Okay, n minus k pr. Okay, in next class we shall discuss other problems and also circular permutation, and permutation contains other restriction. Okay.